Hey, geometry classes, Mr. Mitchell here. I'm going to set you guys up for a lesson today on proofs in geometry. And this is what we've been working towards in this entire chapter on logic and reasoning, proving math. Okay, so it goes this way. You'll need 3 pieces of paper total. And I'm going to do a little just general review on this piece of paper. Then the video will cut to a different piece, and you guys will try one proof on paper and then have a look at the Big Ideas textbook assignment, which is about 16 problems that go with it. Proofs is a challenge to teach because we have to set you up to discover. So what I'm going to cover here is some things that have been touched on in the last week or so that will come up again. We've seen these. They'll come up again in today's assignment. And there's a couple more proofs in the assignment today for you to try. One piece of paper, then we try a single proof from start to finish, and then you guys try an assignment. Okay, so here I go. It's section 2.5 in the book, which has many more examples of proofs with answers given if you look at your online textbook. And we will use a 2-column proof. As a format. There are many kinds of proofs. The 2-column proof is pretty common. It has 2 parts. Statements and reasons. So there's 2 parts of a 2-column proof. And a little picture of it, it's going to look like this with statements on the left and reasons on the right. And you will put things in 2 columns. So you'll write information here on the left as a statement in math language, and then a reason with a few words on the right. So there's a general model of how 2-column proofs are going to look. 16 problems are assigned in the online textbook. And then I want to touch on something once again that Ms. Sitek brought up yesterday. We'll see these properties today. And properties are established math that we can use as reasons. So properties, they help with the reasons. Okay. There is the reflexive, and it's helpful to go up over these a second day. The symmetric, okay, a little more space for the transitive property, and then the distributive property. So at least these 4 are in specific questions, and I just want to cover them with an example that is just using angles. So the reflexive property in math means that if we have the measure of angle A, it is equal to the measure of angle A. Okay, and sometimes that's useful because we're looking to reflect something across across an equal sign. So this seems redundant, but it can be useful as a reason. The symmetric, I'm going to put this in a conditional statement. The symmetric property, if the measure of angle A is equal to another angle that we'll say is the measure of angle B, then we have logical reasoning we can use. If the measure of angle A is equal to the measure of B, then we may also say that the measure of angle B is either equal to the measure of angle A. Okay, so that's the symmetric property. The transitive property, if the measure of angle A is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C, believe me, it's worth writing these things down more than once. It'll help commit it to your memory. Then we may say, by the transitive property of equality, we may make a leap that the measure of angle A here can be connected to this one is equal to the measure of angle C. And we haven't seen maybe this measure of the angle for a while, so this is useful today. And I want you to be refamiliar with saying the measure of angle A. And then the distributive property is a property in mathematics that says if I have a multiplication and something in a parentheses, so I'm just using generic variables here, and I'm going to say y plus z. So if variable x is multiplied by two variables that are added in parentheses, then I may do this thing from the past where we draw arrows. And I'm going to multiply each individually in the parentheses by x. So this is equal to x times y, implied multiplication, writing two variable letters next to each other, plus x times z. That's the distributive property. And we will see this go in the opposite direction today. Lastly, I want to cover complementary. And let's use the symbol angles. So complementary angles, they add to 90 degrees. Okay, so here's a picture of two complementary angles if I drew a ray. Okay, angle 1 and angle 2 are complementary. I know because they add to 90 according to the symbol. Supplementary angles add to 180 degrees. And a picture that makes sense to go with here is a straight line, a ray, and these two angles shown there, angle 1 and angle 2. They will sum to 180 degrees. And then also a memory is going to come up, and this one comes up all year, so I like to bring it up often. Vertical angles. Vertical angles look like this. I'm going to make these line segments with defined lengths, have vertical angles. Vertical angles are across from each other. So angle 1 and angle 2 are vertical. So this page is kind of a review of a couple of things that we're going to be needing in the second part of the video. and maybe just pause your video and catch up with a nice table of information that you can use as a reference.